Hi everyone, welcome back to the Math Society. So this week we'll end off with chapter 16, which is kinematics. So this is going to be the last past paper questions for 2020. So let's get right into it. Okay, so number one, it says that a particle P moves in a straight line such that t seconds after passing through fixed point O, acceleration is a, and it's given by a is equal to minus 6. So when t is equal to 0, the velocity is given, which is 18. So you need to find the time at which p comes to the instantaneous rest. So we know that if it comes to rest, it means v is going to be equal to 0. So first of all, we need to integrate it, so which is v equals to integration of a of dt, where you will get integrate of a minus 6 dt. So that's going to give you minus 6t plus c. So when t is equal to 0, v is 18, right? So then 18 is going to be equal to c, because it's 0. So v is going to equal minus 6t plus 18. And then if you have 0 equals to minus 6t plus 18, 6t is equals to 18, and you have t equals to 3 seconds. So that's 3 seconds. And B, it says that find the distance traveled by P in the third second. So you need to find the one in the third second. So we'll integrate it first, which is S is going to equal V of the velocity of dt. And we know that it was 6t, so minus 6t plus 18 dt. And that is going to give you minus 6t squared by 2 plus 18t plus c. So if you multiply it, it'll be minus 3. Right. Minus 3t squared plus 18t plus c. And when t is equal to 0, s1 is going to be 0, then it means c is going to be equal to 0. So therefore, s is going to equal to minus 3t squared plus 18t. And you're going to find t equals to 2. So that's s equal to 2 to 4 minus 12 plus 36. It's going to give you 24. T equals to 3. S is going to equal to 9, 3, 27. Plus you get 3, 54. That's going to go 27. So for the third second, you just need to minus them. So which means 27 minus 24. And this is going to be equal distance. So that's going to be 3 meters. And that is your distance. And moving on to number 2, it says that a particle P moves in a straight line such that its displacement xm for 6 point is given at this. Find the speed of P when t equals pi. So it's the same way. So it's going to be P multiplied by 2, 10, 20, and that's going to be cos 2t, right? So that's going to be, the 20 is going to be speed. Then speed, if you want, that is just going to be 20. And it says find the value of t for which p is first at rest. At rest, we know that v is equal to 0. So 20 cos 2t equals to 0. That you will have cos 2t equals to 0. 2t cos inverse 0, that's pi by so 0 equals cos inverse 0. So pi by 2, so 2t, then t is going to be pi by 4. And then it says find the acceleration, you need to find a. So we know that a is just going to be minus 40 sine 2t, right? So then that is minus 40 sine pi by 2. That's 2, you multiply 2 and 2. So that's going to be just minus 40, and that is your acceleration. Okay, so for 2, it says that the diagram shows the velocity time graph for particle Q traveling in a straight line. Accelerate at 3.5 meter for the first 10 seconds, and then travel is constant for 10 seconds. Particle that accelerates and come to rest. Distance travel during the entire through the interval is 20 t between 20 and 25 is 112.5 meters. So that is probably the distance. So you know that we need to find v. So first of all, this is going to be 0, 0. We want to find v, we know that it is 10, v. So let's try to find v. So it's just v minus 0, because we know the acceleration 3.5, so we're going to use that, yeah? And 10 minus 0, that has to equals to 3.5. So then v is just going to be equals to 35 meters per second. So we know that even here it is going to be 20, 35. And this will be 35 as well. And then it says to find the velocity of q when t is equal to 25. We need to find when t is equal to 25, right? So then it is going to be half multiply 35 plus. So we're going to find it right here. So we're just going to give this as 25 comma x. Give an unknown of x. Here we're just going to give it as y comma 0. Then you just need to find x. So it's going to be, if you remember, this is going to be at 20 to 25. They already give you the area, which is 112.5. So we know that if it is area under the line, that's the distance, right? So it's going to be half plus, it's going to be 35 plus x multiply 5. And that was equal to 112.5. So that is 35 plus x equals to 45. So you have x equals to 10. So now we know that this is 25 comma 10. And moving on to number C, says to find the value of t when q comes to rest. So we're going to find the, when q comes to rest, so we're going to find the gradient first. So gradients, and let's see, it's going to be 10 minus 35 by 25 minus 20. So that's going to give you an m of minus 5 meter per second. And so if you use it, it's going to use y, it's going to be 0 minus 10 by y minus 25, right? So that's going to have to equal to minus 5. So it's minus 10 equals to minus 5y plus 125. 5y equals to 135. Y is going to equal to 27. So then we know that t is going to equal to 27. Okay, so for number 4, it says that at time t seconds, a particle traveling in a straight line has this acceleration. When t equals 0, a particle is 4 meters away from a fixed point of O, traveling with 8 meters per second away from O. You need to just find the velocity of the particle at time t seconds. So we're going to have v equals to 2t plus 1. Sorry, it's 2, we're going to just use it. So 2t plus 1, half multiply half plus c. That's already done. 2t plus 1 half plus c. So that's when t equals to 0 and v equals to 8. 8 is going to equals to 0. So that's 1 plus c. So c is going to equals to 7. So then you'll have v equals to 2t plus 1 half plus 7. And so let's find the displacement of the particle from 0 at times. So we're going to use v equals to, let's write this back first. V equals to 2t plus 1 whole power half plus 7. So then you will have your differentiator. You'll have s equal to 2 by 3, 2t plus 1, 3 by 2, multiply with half plus 7t plus c. So when t is equal to 0, and s needs to be equal to, I believe, 4. So that's why 4 equals, if you put 0 in, so we're just going to cancel out. So you have 1 by 3 plus c. C is going to equal 11 by 3. So then s is going to be equal to 1 by 3, 2t plus 1, 3 by 2, 3 by 2 plus 7t plus c, which is 11 by 3. And that is your displacement equation. And moving on to number 5, it says that a particle travels in a straight line. So first, it's only in a straight line. It passes through a fixed point, particles with a velocity of 3 meters per second. So firstly, it is moving in a straight line. This is going to be a straight line at 3 meters per second. Particle continues at this velocity for 60 seconds and then decelerates at a constant rate of 15 seconds. So firstly, it's going to stop at 60 seconds. Oh, so wait, 60 seconds, yeah. 60 seconds. And it says constant rate for another 15 seconds at velocity of 1.6. So it means it went down straight. Okay, this has to be straight. And that was another 15 seconds. So that's going to be 75 seconds. And then you will have this at, I believe it has to be at 1.6 meter per second. And then decelerates as a constant rate for 5 seconds to reach point A. So then it just decelerates for 5 seconds, and that should be 80. Yep, and that's just your sketching of the velocity graph. And they try to find the distance between O and A. O and A. So we know that this is going to be an A where it stops, right? So area, we're going to find this square first, which is going to be 60 multiplied 3. Which is going to be 180 plus the triangle. So it's half 3 multiply 1.6 and multiply 15. Oh, not trapezium. Plus half multiply 5 multiply 1.6, right? This one is the rectangle one, and this one is the trapezium one. This 3, 1.6, and then the 15. Yep, trapezium. It is the square, trapezium, and then the triangle. 63, 180 plus, so if you all plus it, you'll get 218.5 meter. And that has to be your distance, yeah? Because distance, we always know that it is area under the curve. And for C, it says to find the deceleration in the last 5 seconds. So we know that it is 1.6 here. And then we know the 75 and 80, so we can use it through the gradient. So that's going to be 1.6 minus 0 by 75 minus 80. And that's going to give you minus 0.32. We're just taking two points. So deceleration equals 0.32 meters per second. And that is your deceleration. And for number 6, it says that it's already given a diagram. So the velocity graph is given, travels 275 meters in 20 seconds, final velocity of v. You just need to find the value of v. So we have to find the area first because it says it already gives you the distance or area. You're gonna have 2 trapezium. So one in here and one in here. So it's first trapezium, half multiply 60 plus 40. And that's 30. And then plus half multiply 30 plus v, and that's going to be 30 as well, 90 minus 60. So that's going to give you 215, and that's going to have to equal to 2775. So we get 1500 plus 30 plus v by 15. So you divide it by 15, you'll get 85 equals to 30 plus v. V is just going to equal to 55 meters per second. So here it's just going to be 55. And write down the acceleration of P1, T is equal to 40. So T is 60, that is 20, 30, 40 right here. And we see no slope, so it means that the acceleration is just going to be 0. So acceleration of P, okay, it's going to be 0 as there is no slope present. Yep. And we'll move on to number B. It says that the acceleration A is equal meters per second square of a particular Q traveling in a straight line is given by A equal to this, T equals 0, particular point will travel with velocity of 10 meters per second. Find the velocity of Q at time T. So first we want to find this one first. So that's going to be V equals to 6 by 2 sine 2T plus C. So we're just integrating it. So and then V is going to equal to 3 sine 2T plus C. So V is going to be 10, right? So that's 3 sine 0 plus C. C equals to 10. So V is going to equal 3 sine 2t plus 10. And then number 2 is to find the displacement of Q from 0 at time t. So we're going to find the displacement, this differentiation first. We're going to differentiate it. So we're going to have minus 3 by 2. Differentiating this one. So cos 2t plus 10t plus c. Oh, sorry, differentiating. Differentiating. T equals 0, S equals to 0, 0 equals to minus 3 by 2, right? So that's just 0 plus C. C equals to minus, oh, sorry, 3 by 2. If that's how you have 3 by 2. S is equal to minus 3 by 2 cos 2t plus nt plus 3 by 2. Yep. Not differentiating, I mean integration, yeah? Okay, so for number 7, say so the diagram shows the XT graph for runner where displacement 8 is measured in meters in time. You need to just draw the VD graph for the runner. So this one is looking for the V meter per second square. So we're just going to have to find it as the M, which is going to be like the rise by run. So here we have 100 by 50. It's going to be 2 here. This one's 100. Oh, sorry. This one's 50 by 20. So that's going to be like 2.5. And this is 150 by 40. So that's going to be by deceleration. So it's going to be minus 3.6 something. So first of all, 2. So over here, 2 here. It's supposed to be a straight line, but it's going to be here until 50. Yeah, and then we have from 65 to 85 is 2.5. And you're gonna have here to it's going to be minus 3.6, yeah. Yeah, so have to be a straight line. Total distance. So it's just distance. They run 100 meters before, 50 meters, and then go back 150. So it's 150, 100 plus 50 plus 150. So that's a total of 300 meters. And then you give to the displacement 8 meter by 6 cos acceleration. So you're gonna v equal to dh by dt. That's going to be minus 6 sine 3t plus pi by 3 multiply 3. So that's going to be minus 18 sine 3t plus pi by 3. And a is equals to dv by dt. That's equal to minus 54 cos 3t plus pi by 3. So when t is equals to 2 pi by 3, a is going to go to minus 54 cos 2 pi plus pi by 3. And it's going to give you a solution of minus 27. And number 8. So it says the particle moves in a straight line such that t seconds after passing a fixed point, O is displacement, O is s meter, where s equal to this. Expression for velocity and acceleration. So it's v equal to ds by dt. So it's going to be 2 e power 2t minus 10 e power 10t. Oh, sorry, 10 e power t minus 12. And acceleration, dv by dt, 2 to 4 e power 2t minus 10 et. And that's just, it just asks you the expression also, that's it. So it's a find the time where the particle is instantaneously at rest. So e is going to be 0. So it's here you have 2 e power 2t minus 10 e power t minus 12 equals 0. So then you have e power 2t minus 5 e power t minus 2, 6, 12, 0. You can change your e power t minus 6 to e power t minus 1. Oh, sorry, plus 1. And equals 0. E power t equals 6. T equals to ln 6. Power t equal minus 1 doesn't exist. I reject it. So you have t is equal to ln 6. And say to find the acceleration. So acceleration A was 4e power 2t minus 10e power t. 4e power 2t minus 10e power t. And our time was t equals to ln 6, isn't it? So A goes to 4e power 2 ln 6 minus 10e power ln 6. That's 4 multiplied 36 minus 10 multiplied 6. That's 144 minus 60. And that gives you 484. And that is your acceleration. And that's it for today's video.